Now I want to talk about protein production. So how can we mathematically model protein production? We have this X gene activates Y gene. Let me briefly review this process. So we have Y gene here and X gene here. And from X gene, X protein is produced. And this protein activates Y gene and Y protein is produced. Now we call the concentration of X protein X and the concentration of Y protein Y. The question is, how can we mathematically model the relationship between X and Y? Here, let's have a very simple mathematical model. Y of I is equal to some parameter P sub xy times X of I minus 1. This means that current Y protein concentration depends on previous X protein concentration. Because X is activating Y, if this X protein concentration is high, then Y protein concentration will be high as well. And if this level is low, then Y will be low as well. Pxy is production parameter and it is a real number. We will define P sub xy as a number always positive. So it's a positive real number. So if you have Y of I equals Pxy, X of I minus 1, this is a positive number. We have activation. So X is activating Y. But in case we have negative P sub xy times X of I minus 1, this is positive number, but we have a negative sign. So the whole thing becomes a negative number. And we have inhibition. As X increases, Y decreases. Now we've seen this model. Y of I is P sub xy times X I minus 1. And this is a linear time invariant differential equation. Let's have another model. This time we will have nonlinear time invariant differential equation. And what do we have here? What if X I minus 1 is 0? There is no X. Then this value becomes 0 and this value becomes 0. So we have a 0 over 1, which is 0. How about if X I minus 1 is infinity? Then we have Y max times infinity over 1 plus infinity. Since this is so small compared to this, we can ignore this value, 1, and we can say that it's Y max times infinity over infinity. And infinity cancel out, and we are left with Y max. So what does this mean? It means that if you have a very large X, then you will have a maximal Y protein concentration. In other words, if you increase X indefinitely, it doesn't mean that Y will increase indefinitely. Because within the cell, there is a limited resources. The number of protein production factories called ribosomes is limited. And other resources also limited. So Y protein concentration cannot increase indefinitely. If you draw the plot that shows the relationship between X of I minus 1 and Y of I, when this is 0, we have 0 here, right? And when X of I minus 1 is very large, we reach this value, which is Y max. It will be something like this. And this shape is S shape, and this function is actually called a Hill function. So here we have nonlinear time invariant differential equation we saw previously, and that function is Hill function, which is shown in black. And now I want to approximate this Hill function using differential equation that we saw previously. So Y of I is equal to Pxy, X of I minus 1. This linear time invariant differential equation can be used to represent this red line shown here when X of I minus 1 is between 0 and A. So when X of I minus 1 is between 0 and A, we can use this equation. And the slope is Pxy. In case X of I minus 1 is greater than or equal to A, we can say this is just Y max. And again, we know that this S function reaches y max as x of I-1 increases. And from now on, when we model simple two-gene regulatory network, we will use this equation, assuming that our x varies from 0 to a.